Afternoon, and welcome to this session of Journal Review. The topic that I want to discuss today is on the effects of bioinformatic global depletion on human RNA-seq DEG analysis. And this particular article was published in 2023, which is relatively or very recent, and was published in the Scientific Reports Journal. This is a summary of the article. The failure to deplete hemoglobin RNA prior to sequencing has a negative impact on the sensitivity to detect disease-relevant gene expression changes, even when bioinformatic removal is performed. So it is actually recommended to use kits such as globin-0 or ribo-0 prior to doing the RNA sequencing experiments itself. Well, before getting in depth, the reason why we decided to do a review on this particular topic is because of this scatter plot. On the x-axis is the mean read count for correct RNA data, and on the y-axis is that of GTEx. And for some of you who don't know what GTEx is, the GTEx is a public database for RNA-seq data. And as you can see on this scatter plot, there's a really high expression of this particular gene family, namely HbA1, HbA2, and HbB, which are all hemoglobin or globin genes. And you can see that the scale is on millions, so the million read count have been shown for these genes. And it has been known before that as Field et al. Says, the RNA, the globin can account for up to 70% of whole blood RNA population. And this can actually introduce the bias and reducing sensitivity to detect low-level transcripts in the blood transcriptome, which is very problematic when we want to do DEG, for example. One way whereby we can deal with the problem of high expression of hemoglobin is by depleting the hemoglobin by using a kit prior to sequencing. The authors have shown in this paper that in the box plots, that when we use a kit, we get effective depletion of hemoglobin around 0.2 to 1.6% of the total population, while when they did not use the kit, there was shocking 36 to 80% of RNA being populated by the globin. Alternative measure whereby you can deplete the globin gene is by using bioinformatics. And what the authors have discovered is that bioinformatics depletion cannot recover the bias due to the high hemoglobin in DEG. So when the authors conducted DEG for tuberculosis for kit depleted and bioinformatic depleted independently, what they could find was that there is a significantly low presence of DEG for bioinformatic depleted. And when they did the enrichment test after DEG finding, they could see the significant enrichment modules for kit depleted, whereas no modules were found for bioinformatic, which is critical for the RNA sequencing, post-RNA sequencing experiments.